Welcome all. In this lecture, we will discuss about the properties of Fourier transform. So these are the properties of Fourier transform, and we will discuss each in detail in coming lectures. First is linearity. So the property linearity is defined as if x1 of j omega is the Fourier transform of x1 of t, and x2 of j omega is the Fourier transform of x2 of t. There are two signals, x1 of t and x2 of t, and their Fourier transforms are x1 of j omega and x2 of j omega. Then linearity property states that the Fourier transform of the function a into x1 of t plus b into x2 of t will be equal to a into x1 of j omega, that is Fourier transform of first function, plus b into x2 of j omega, that is the Fourier transform of second function. So this is the linearity property, and we can have the proof as, so we have to find the Fourier transform of ax1 of t plus b x2 of t. So Fourier transform of the function, general function x of t, that is x of j omega, is equal to Fourier transform of x of t is equal to integral minus infinity x of t e raised to minus j omega t dt, the general equation. So in order to find the Fourier transform of a x1 of t plus b x2 of t, this function, we have to replace this x of t by this. So we can, the Fourier transform of this function will be equal to, instead of x of t, we have to write this function here, ax1 of t plus bx2 of t. Then we can multiply both terms by e raised to minus j omega t. So it become a into x1 of t into e raised to minus j omega t plus b into x2 of t into e raised to minus j omega t dt. Then we can split the integral. So the first term, so integral ax1 of t e raised to minus j omega t dt plus integral bx2 of t e raised to minus j omega t dt. Then this, out of this integral, a is constant, so we can take it outside. Here also b is constant, so we can take it outside. So it become a into integral x1 of t e raised to minus j omega t dt plus here b into e raised to integral x2 of t e raised to minus j omega t dt. So if you are looking here, this is actually the, we have the Fourier transform of x of t as this term, x of j omega is this. So this is, if you are looking here, comparing these two, this is the Fourier transform of x1 of t, that is x1 of j omega. So it become a into x1 of j omega, and this is the Fourier transform of x2 of t, that is x2 of j omega. So it become a into x1 of j omega plus b into x2 of j omega. So hence the proof. Next function is, next property is time shifting. So suppose we have the signal x of t, the Fourier transform of this x of t is x of j omega. Then the Fourier transform of the shifted function, that is x of t minus t0, we are shifting the signal by t0, a constant. So that Fourier transform of that is e raised to minus j omega t0 into x of j omega. We have the Fourier transform of x of t is x of j omega, then the Fourier transform of the shifted function will be equal to e raised to minus j omega t t0 into that Fourier transform of that function. And proof is, we have the Fourier transform equation as this. So we have to find the Fourier of x of t minus t0. So instead of x of t, it will be x of t minus t0. Then we can substitute as v is equal to t minus t0. Then t become this, t0 become here, so v plus t0. So dt will be equal to dv, this is constant, so dt0 is 0, so dt equal to dv. Again we have t equal to v plus t0. Then when, or v equal to t minus t0, so when t equal to infinity, v is equal to this t minus t0, so minus infinity minus t0, it become minus infinity itself. When t equal to plus infinity, infinity minus t0 till infinity. So limits are again minus infinity infinity. So it become integral minus infinity infinity. The new limits are minus infinity to infinity. T minus t0 become v, and this t become v plus t0, dv become dt become dv. Okay, so this is the new integral we have to find. So we can split this e raised to minus j omega v into e raised to minus j omega t0. So if you are looking here, this e raised to minus j omega t0 is a constant. Omega is constant, t0 is constant, because integral is with respect to v. So we can take it outside. So this term can be taken outside. First is integral minus infinity x of v e raised to minus j omega v dv. So if you are looking here, this is actually the Fourier transform. So this is similar. Okay, x of v e raised to minus j omega v dv. So this is actually x of j omega. So it become e raised to minus j omega t0 x of j omega. So hence the time shifting property is proved. Next property is time reversal. Means if you have the signal x of t and the Fourier of that signal x of t is x of j omega, then the time reversed signal x of minus t has the Fourier transform of x of minus j omega. The proof, this is the equation for Fourier transform. Then instead of x of t, we have to put x of minus t, then substitute v equal to minus t, then t equal to minus v, then dt equal to minus dv, and we have to find the limits. So for when t equal to minus infinity, v is minus infinity, so it becomes plus infinity. Okay, when t equal to minus infinity, v equal to plus infinity, then upper limit is infinity. So when t is plus infinity, v equal to minus t is plus infinity, so it become minus infinity. So the limit is changed into, previously the limit was minus infinity to infinity, here the limit become plus infinity to infinity. Okay, so it should be clear that the limits is changed as plus infinity to minus infinity. Minus t become v e raised to minus j omega t become minus v, and dt become minus dv. So this is the new integral. So we can take the minus outside, so it become minus, this minus, integral plus infinity to minus infinity x of v e raised to minus j omega into minus v. So it become e raised to j omega v. Again this is integral, so this is minus integral plus infinity to minus infinity. So it become integral minus of integral plus infinity minus infinity is plus integral minus infinity to infinity x of v e raised to j omega v dv. So this is actually x of j omega. So if you are finding x of minus j omega, omega become minus omega, so it become e raised to j omega t. So if you are comparing these two, these are same. So this is actually x of minus j omega. So hence it is proved that Fourier of x of minus t is equal to x of minus j omega. Hence the proof. Next property is time scaling. So again we have the signal x of t, and Fourier transform of x of t is x of j omega. Then the Fourier transform of the time scaled signal x of Fourier of x of at, the time scaling is at, is equal to 1 by absolute value of a into x of j omega by a. So again we can start from finding, this is the general equation for finding the Fourier transform. We can start from finding Fourier of x of t. So instead of x of t we have to replace by x of at. Okay, so again there will be two cases. Case 1, a is positive, so let us substitute a equal to plus p, a positive value. Okay, so it become integral x of plus pt e raised to minus j omega t dt. And again we can substitute v is equal to plus p into t, so it become here t become v by p, and dt will become 1 by p into dv. So p is a constant value. Okay, a constant value, so 1 by p dv. and again we have to find the limits. So when for taking minus infinity, so when t is minus infinity, v is also p into infinity, so it become minus infinity. Okay, minus infinity. Then we can take the upper limit infinity. So when t equal to infinity, v equal to p into infinity, that is infinity again. So limit is not changing, minus infinity, no limit is also minus infinity to infinity. So minus infinity x of pt become x of v, t become v by p, and dt become 1 by p into dv. Okay, so this is the new integral, and again we can take 1 by p outside, it is constant. The integral is with respect to v. So 1 by p integral minus infinity x of v e raised to minus j omega by p into v dv. So if you are considering this equation, this is actually, here it is omega by p. So this is x of j omega, so this is x of j omega by p. So 1 by p x of j omega by p. Then case 2, here a is positive, then case 2 is a is negative. So a is equal to a negative value minus p. Okay, minus p. So this integral become x of minus pt, a become minus p, t into e raised to minus j omega t dt. And again we can substitute as v is equal to minus pt, so t is equal to minus v by p, and dt is equal to minus 1 by p dv, p is constant. So if you are considering the limits minus infinity to infinity, so when t equal to minus infinity, v is equal to minus into minus infinity, so it become plus infinity. Okay, t is infinity, p is a constant, it will not change any matter. Also minus into minus, so it becomes minus into minus infinity plus infinity. So when t is minus infinity, v is plus infinity, so lower limit is changed, then upper limit is infinity here. So when t is infinity, v is minus infinity, minus into plus infinity, so it become minus infinity. So the limits is changed into plus infinity to minus infinity, plus infinity to minus infinity. Then x of minus pt become x of v, this t become minus v by p, and dt become minus 1 by p dv. So we can take this minus 1 by p outside, this constant. So minus 1 by p integral plus infinity to minus infinity x of v e raised to minus j omega minus v by p dv. So this is actually minus integral plus infinity to minus infinity, so it become integral minus infinity to plus infinity, this minus of integral plus infinity to minus infinity, when limits are changed become negative. So then this become x of v, this become, we can take as e raised to minus j omega by minus p into v, multiplying this omega, this minus p by minus p can be taken with omega, so omega by minus p into v. So again if you are comparing with this, here it is omega, here it is omega minus p, so this is x of j omega, so this is actually x of minus j omega by minus p. Okay, this is actually omega minus p. Okay, so x of j, this omega will become x of j omega by minus p. So in order to find f of x of at, we have to combine these two. Okay, in either a is positive or negative. So in both, so we can find f of x of t as combining these two. So if you are considering this part, okay, x of j omega by p, here it is x of j omega by minus p, means when a is plus p, here it is plus p, when a is minus p, here it is minus p itself, means this part is actually x of j omega by a, here it is plus p, here it is minus p, so it is combining, we can write as x of j omega by a. But here when a is plus p, this is plus p, a is negative, a is minus p, it is plus p itself. Okay, means when a is positive or negative, it is positive itself. Okay, here it is positive, here it is positive, means it is actually absolute value of a, modulus of a. So 1 by modulus a into x of j omega by a, hence the proof. So next is frequency shifting. Okay, so this is we have the function x of t, and Fourier of x of t is x of j omega. Then we are shifting the frequency omega minus omega 0. This is a constant value. We are shifting the in the frequency domain. The frequency is shifted, so it becomes x of t e raised to minus j omega naught t in the time domain. Means f of x of t e raised to j omega 0 t is equal to x of j omega minus omega 0. We can have the proof as this is the general formula. So instead of x of t, we have to write x of t e raised to j omega naught t. Okay, so we can multiply these two. So it become e raised to minus here j omega, here it is omega naught, so my omega minus omega 0, combining these two. Okay, so again if you are comparing these two, this is actually x of j omega, so here it is omega, so this is omega minus omega 0, so it is x of j omega minus omega 0, so hence the proof. So with this we can wind up the session. Thank you.